Okay, so we're gonna take a pause then from what you've been working on. Of course, you're welcome to keep those sheets of paper if you want, so you can go ahead and go through it in your own time, especially over the break or kind of over the weekend, or for your upcoming exam, get in your study groups, etc., etc. Did you like that? Did you like the assignment?
Yes, I like that.
It's fun when it's like this, right? So what I want to do is I want to take a little bit of time here and talk about at least some of the at least the first section, the beginner questions. Let's talk about the first one. Francis wants to know if the redesigned website for his jelly and jam business improved traffic. Before the redesign, he averaged 398 unique visits a week. What's the null and alternative hypothesis for any tests he runs? So this question is largely about if it's a one or a two-tail test. Is it a one or a two-tail test? One-tail test. How do you know? It's like that one. Yeah, I made that really clear, didn't I? So this is a one-tail test. Now, how, using the null hypothesis, how do we indicate if it's a one-tail test? So how do we indicate that? Let me make a handy chart for you. What's H0 stand for? No. It's exactly null, or null hypothesis. And H sub A? Alternative hypothesis. So if it's a one-tail test, we use these symbols. The equal to, we have to include the equal to, or greater than, the equal to or less than. And then the alternative hypothesis would just be whatever those do not include. So in this particular case, wants to redesign the website for Jelly Beans. Is it an improvement if fewer people come to his website?
No.
No. Good. So, null hypothesis would be is less than or equal to 398. Right. And that means our alternative hypothesis would be mu is what? No, not equal to, because we can't put the equal to, right? Just greater than. So don't I set this up in such a way that these match, just as these match. Okay. Put them in that order. If I should be, we make that an or. That's really all you have to worry. I thought H dot colon mu this stuff. That's like the symbol. I saw some people writing the whole thing out in words. I mean, I guess that's fine, but this is faster.
Wait, what does that get thing mean?
Mu. It's our population average.
Okay.
We're saying, look, is the mu just the same or less? Or is it bigger? Is there an improvement? 2. Catherine's the new CEO of an exercise equipment company, and she wants to know if her time as CEO has affected the return rates of treadmills. Before becoming CEO, 8% treadmills were returned. What's the null hypothesis and alternative hypothesis until she runs? So is this a one or a two-tail test? Two-tail test. How do you know? Exactly. Right. Has affected. That could go either way. So when we use, when it's a two-tail, the null uses the equal sign. It's exactly the same, nothing's changed. If it's the alternative, what do we use if it's the alternative? Does not equal. Right. So just as there's no overlap between these two, there's no overlap between these two. What would be our null hypothesis here? So it equals 0.08. percent. And this is the tricky part. What goes here?
Not equal.
No, we got equal here. And you're right, we have non-equal for the alternative. What goes here? What does it equal?
Mu.
So it's tempting to write mu, but this isn't. This is a special kind. This is a special case. You write pi, because pi is the population proportion. Don't, as I've seen people do both in this class and in the previous section as well, think pi is the same thing as 3.14. In statistics, pi is a variable. Statistics, pi is the population average. Just like mu and x bar, mu is the population average and x bar is the sample average. Pi is the population average and p bar, sometimes it's p, but I don't really see p bar, is the sample average. Or is the sample proportion average.
So the mu is what?
The mu is the population average.
Okay, that's the population average.
Yeah, and there's two different kinds of population averages. One is mu for anything, for anything that's not bounded. It could be a negative value, it could be 11 million, whatever it is, right? It can be anything. Pi is specifically for proportions. So anything time you see a percent, that's pi. That's proportion. Yeah.
Okay.
Well, you can use pi for two tails or one tail. So, like, if this was like, I don't know, like maybe she wants to know, not did the return rate change, maybe she wants to know did the return rate improve. And then the only thing we'll be changing here is this equal sign and unequal sign to something that matches the one tail. Or maybe he wants to know not if we improved the visitor, but if it changed. Maybe made it better, maybe made it worse, right? In which case we would change these to equal and not equal. So you can mix and match. There's lots of really fun options. Any questions on 1 and 2? Great. All right, let's talk about 3. So we're going to build on that previous question. Let's imagine the company sold 900 treadmills. Since Catherine became CEO, we got that 6.5% return rate based on 900 treadmills since she's been in charge. We know that this is a proportion, so we got to do some math. We can put in the numerator here, the denominator here, and I guess we just got an n here. Oops. I'm sorry, the calculator now here. What's the numerator equal to? What 065? This. Oops, and of course I didn't put an equal. That's not. Great. So that's our numerator. What's our denominator? Well, it's going to be 0.08 times 0.92, because that's 1 minus 0.08. We are using the population proportion. The hypothesis test proportion. Yeah, it's still Z. And we divide by how much? 92. Again, if you put in, let me use in this equation. P bar minus I divided by square root of pi times 1 minus pi all over n. Again, if you put in 3.14, you should be confused. Why you're always thinking 1 minus that? That's kind of strange. And 2, of course, that will be negative, and so you can't take the square root of a negative. So, again, that's going to be bounded between 0 and 1. And we get that. And then, of course, we just take this value, divide by the other one, and we can proportion the acid value. You can just mentally make it positive. But I do the absolute value step to remind us that before I started doing the absolute value step, I literally had lots of students like, oh, it's negative. I guess it won't be greater than the critical value, and they kept failing to reject it all. So I'm trying to fix that and focus on the absolute. You take the absolute value because you care about, technically critical values from both regards. So. And so we get something that is about 1.667.
Because what if we did it the long-hand way?
What do you mean the long-hand way?
Like, would you just shove it in the water?
Oh, you actually, I don't care how you do it.
Okay.
This is faster.
Okay.
But I don't care if you wrote it out and then pulled out a calculator and did all these steps individually. But I encourage you to do it this way because you save some time. Then we get about 1 point. I got something slightly different. I think this was a rounding issue. Yeah, I got. Let's update that. Yeah. Yeah. At these levels, it doesn't necessarily matter because in both cases, what do we conclude? Did we reject or fail to reject it all? Exactly. It's statistically significant. So we reject our null hypothesis. Granted, we were using a pretty sad confidence level of 1.645. Z-score 90%, a confidence level of 90%. Z-score 1.645. That's pretty sad. Typically, our minimum threshold is 95%. But... Any questions? On that? Yeah.
You said yes, you reject it all?
Mm-hmm.
Can you just explain the terminology?
Because our calculated value here is greater than our critical value of 1.645. So therefore, we reject the null at 90% confidence. Okay. Notably, if we did it at 95% confidence, where the critical value is 1.96, we would fail to reject, because this will be less than that. Any other questions? So, I also asked for type 1 and type 2 error examples. Does anyone want to give me their type 1 and type 2 error examples? Anyone? Yeah.
So, type 1, we said secondly, buying a used car that turned out to be bad.
Mm-hmm.
To be in bad condition.
That was your type 1?
And then type 2, not buying a car, not buying a used car that was in perfect condition.
Okay, I mean, you're right. It's kind of boring, you just flipped it. But you're right, you're absolutely right. So both of those work for type 1 and type 2. I didn't ask for 2 of each, though. I knew you could just swap it around. You want to get another one?
Type 1 versus type 2.
Yeah, like you had some numbers in your hand, like, I'm not going to play those numbers, and those numbers win. Right, absolutely. Again, doing the thing, we just swap it around. Right. The valid thing to do. For those of you curious, the ones I suggested, majoring in something that you shouldn't have majored in would be a type 1 error. Right? You made a mistake, right? You rejected your null and you majored in something silly, or something maybe you didn't enjoy or bad at. Also, ordering food that turned out to not taste good. Also a type 1 error. Type 2, ignoring a shirt that would look and fit very well on you. So, of course, you missed out on a great opportunity to, show everyone your great fashion sense. And not posting something on Facebook that's actually really funny. Right? You came up with a great joke, and you're like, I'm not going to put it on, right? Oh, you should have put it on. Right? Your null hypothesis is don't post every random thought that comes to you. Only time assume that is your null hypothesis. And, of course, you made a mistake by keeping that quick joke to yourself. So, are there any questions on this stuff? So, of course, that's the beginner questions. Also, the whole answer key up online. And then if you have any questions about the other ones, feel free to email me. And have a great week, everyone. I'll see you in a couple of weeks. All right.
or not a couple of weeks, but what is it? Yeah, 10 days or whatever it is.